Think about the process of building a ship in a bottle. There's this certain romance to the manual labor of it all.
Oh, yeah, like the patience it takes.
Right. You have your tiny tweezers, and you are meticulously placing every single wooden plank.
Gluing down every microscopic rigging line.
Exactly. And it takes forever. I mean, it is so tedious. But there is this deep, unshakable sense of, well, total control.
Yeah, you own every single splinter in that bottle.
Right. The output is a direct one-to-one reflection of the input. There's zero surprises because your own hands put it there. But imagine you wake up tomorrow, and instead of tiny tweezers, you have a magic wand.
Okay, magic wand.
Yeah. You wave it, you verbally describe the ship you want, and boom, a fully rigged Spanish galleon just, appears inside the glass in like 3 seconds.
Which sounds amazing at first.
Oh, the initial reaction is pure awe. That is the ultimate aha moment. But then the anxiety sets in.
Right, because you didn't build it.
Exactly. You lean in, you look closer. Are the sails actually tied to the masts, or are they just sort of resting against them? Is there a microscopic hole in the hull? You actually have no idea how it is holding together.
It's a terrifying feeling, honestly.
It really is. And welcome to this deep dive. Today we are taking a shortcut to understanding arguably the biggest paradigm shift in the history of technology.
A shift that changes everything for developers.
Yes. We are dissecting a brilliant 2026 presentation by a developer known as @LUK036 titled Software Development Flow in the AI Era.
And, we aren't just looking at the surface level metrics here, like how AI tools write code faster.
Right.
The core premise of this presentation is that this technology has fundamentally broken the old assembly line. It's forced a complete rebuild of how humans conceive, structure, and deploy software systems.
And before we analyze the magic wand, we kind of need to understand why we spent decades using the tweezers, right? The baseline for software development, what the source calls the old world, well, it had a very specific physical limit.
Yeah, the old world evolution. It went from the rigid, gated phases of the classic waterfall model straight through to the modern agile and CI/CD pipelines that we use today.
And Agile certainly shortened the feedback loop.
It did, but it never solved the foundational bottleneck, which is that humans were still manually typing 100% of the logic.
Wow. 100%.
Right. The translation layer between human intent and machine execution was literally just the speed of fingers on a keyboard.
Which is so slow. The cognitive load of translating abstract business logic into highly specific syntax is massive.
Oh, absolutely.
When manual coding is that slow and, manual bug fixing takes hours of staring at a screen, a developer's absolute productivity ceiling is permanently capped.
Exactly. And the presentation actually notes that the historical maximum was roughly one module per sprint.
One module. That's it.
That's it. And handoffs between front-end, back-end, and QA roles, they just acted as delay multipliers on top of that physical limit. We spent 40 years optimizing everything around the developer without ever optimizing the raw output speed.
Okay, let's unpack this. Because that historical ceiling has been completely shattered today.
Oh, completely.
Since humans are no longer typing every single line, the entire development loop hasn't just sped up. The source material argues it is entirely flipped in structure.
Right. The presentation redefines the day-to-day workflow as the new dev loop.
The new dev loop.
Yeah. In the old world, a developer's inner loop was sequential. It was mechanical. You type the code, you compile the code, you debug the code.
Right. You wrote it. You executed it to see if it ran.
And you chased down the stack trace when it inevitably broke. But today, the new inner loop is entirely different. It's prompt, then generate, then validate.
Prompt, generate, validate. So the actual execution of writing the syntax has been completely outsourced.
Exactly. The physical act of typing is no longer the bottleneck.
Which means the bottleneck has moved up the cognitive stack.
Yes. It is now entirely dependent on 3 new pillars.
Okay, what are they?
First, your prompt quality. Basically, your ability to rigorously specify your architectural intent. Second, your validation rigor. How aggressively you can verify the correctness of a system that you didn't physically build.
Right.
And third, your design judgment. Knowing what the system actually needs to do and why it matters in the broader context of the application.
It's like the transition from being a line cook to being an executive chef.
Oh, I like that analogy.
Right, because a line cook might spend 4 hours meticulously mincing garlic and, breaking down chickens. They control the knife. But in this new loop, you are the executive chef.
You're running the kitchen.
Exactly. You have a kitchen full of hyper-fast, tireless sous chefs. You aren't holding the knife anymore.
Hmm.
But your instructions to them better be mathematically precise.
They have to be.
Because if you ask for a spicy reduction without specifying the exact flavor profile, the viscosity, and the chemical interaction you want, those sous chefs will enthusiastically hand you a pot of boiling hot sauce that just ruins the dish.
Ruining the entire meal. Yeah, the role shifts from typist to director, and the output metrics from the presentation show why this shift is just mandatory now.
The numbers are crazy, right?
Yeah. A developer's output is now tracking at 3 to 10 times higher than it was in the old world.
10 times.
Up to 10 times, yeah.
Wow.
Every phase of development gets an AI copilot. However, the presentation is absolutely adamant that the human has to remain the definitive decision maker.
The human stays in charge.
Always. The AI is a massive engine of generation, but it lacks architectural foresight. The human provides the steering and the brakes.
Well, if the engine is running 3 to 10 times faster, we really need to talk about what kind of fuel it's burning. Like, what is the AI actually good at producing, and where is it secretly setting traps for us? Because generating code 10 times faster doesn't help if you're just driving 10 times faster into a brick wall.
Exactly. We have to analyze the mechanism behind the multiplier. The speed up metrics in this presentation are heavily skewed towards specific types of tasks.
Let's look at those numbers. For boilerplate code, AI is generating it 10 times faster. For unit tests, it's 8 times faster.
And API integrations are 5 times faster.
Right. But the most staggering metric is formatting and regex regular expressions. AI is handling regex 20 times faster than a human.
20 times faster. And what's fascinating here is that the underlying mechanism driving those specific numbers reveals an essential rule of thumb for the AI era.
Oh, the rule of thumb.
Yeah. AI is phenomenal at expression, but it is fundamentally weak at verification.
Phenomenal at expression, weak at verification. Because large language models are, at their core, probabilistic engines, right?
Yes.
They are just predicting the next logical token based on massive training data sets. They aren't deterministic calculators that inherently know if a piece of logic is definitively true.
That is the exact distinction. Regex is pure pattern matching, which maps perfectly to a probabilistic model's strengths.
Right. Human developers usually hate writing regex.
They despise it.
Mm-hmm.
So the AI excels at expressing that idea in syntactically perfect code. But because it lacks grounding in external reality, its ability to verify its own logic against the actual state of your system is, well, deeply flawed.
And this weakness introduces extreme risks.
Severe risks. The highest risks identified in the source are hallucinated APIs, where the AI confidently calls a function or an endpoint that simply does not exist.
It just makes it up.
Literally makes it up, along with hidden architectural assumptions and really severe security blind spots.
And security is where the probabilistic nature of the AI becomes a massive liability.
Oh, a total nightmare.
The source points out that AI models will accidentally generate SQL injections or carelessly hard-code secrets like live API keys right into the middle of a script.
Because the AI is optimizing for the quickest syntactical solution to the prompt.
Right. It's not optimizing for the security posture of the overall application. It doesn't understand that pasting unsanitized user input into a database query compromises the system. It just knows that that specific pattern completes the function.
It prioritizes the expression of the solution over the defense of the environment. The model is blindly helpful, which is exactly what makes it dangerous.
And I think this requires pushing back on the whole utopian hype of AI development.
Definitely.
Like if this magic wand writes code 20 times faster, but introduces critical vulnerabilities because it lacks contextual awareness, we aren't necessarily moving forward. We might just be building an incredibly fragile, insecure house of cards at lightning speed. You're basically leaving the front door unlocked.
Yeah, applying old world workflows to new world speeds guarantees that fragile house of cards.
So what's the fix?
Well, the presentation insists that a 10x increase in AI velocity does not equal a 10x increase in team output unless the safety net is completely rebuilt. Your effective output is an equation.
An equation.
Yeah. It's AI velocity multiplied by human oversight, multiplied by your CI coverage.
Okay, so if the AI is a probabilistic engine generating occasionally hallucinatory code, the safety net needs to be this immovable deterministic wall.
Exactly.
We need to talk about how traditional tools are being radically repurposed to form that wall.
Right. Traditional tools are evolving into a highly aggressive trust layer. Consider Git.
Good old Git.
Right. Historically, Git was primarily for version control. It was just a way for human teams to collaborate, branch features, and maintain a history of changes.
But now,
In the AI era, Git becomes the ultimate, non-negotiable undo button. Because AI agents can generate massive, sprawling pull requests in seconds, Git serves as the literal state manager.
Just the panic button.
Exactly. If an agent introduces a cascading hallucination, Git allows you to instantly roll back to a known deterministic state. Without it, you are just drowning in machine-generated noise.
Okay, so Git is the panic button,
Hmm?
but continuous integration, or CI, takes on a much more active role. Before, CI was essentially a deployment gatekeeper, right?
Yeah, mostly.
It ran your tests to ensure a human didn't accidentally break the build before shipping to production.
But now, CI is repurposed as the AI hallucination detector.
The hallucination detector. Wow.
Because AI models produce code that looks entirely plausible. The syntax is flawless, the variable names are perfectly formatted. A human reviewer scanning it visually can easily be tricked into approving it.
Because it looks so confident.
Right. But CI doesn't care how pretty the code looks. It is a machine mechanically executing the logic against a rigid set of rules. Therefore, the faster your AI generates code, the more intensely you need CI to catch logical discrepancies that the human eye misses.
It's the trust layer.
Yes, CI is the literal boundary of trust between an AI's output and your production environment.
And here's where it gets really interesting. Because CI is catching these invisible logical flaws, the AI can't rely on visual cues. Like, it can't click through a website to figure out what's wrong the way a human would.
Right.
The presentation points out a massive shift in tooling because of this. AI agents, the autonomous tools actually iterating on the software, they do not use GUIs. They interact entirely through the CLI.
The command line interface becomes the native operating environment for AI agents.
Not the graphical interface.
No, because GUIs require complex visual parsing, which is computationally expensive and highly prone to error for an agent. Text streams in a terminal, however, map perfectly to an LLM's input and output tokens.
That makes total sense.
If you want an AI to effectively navigate your codebase, run tests, and iterate on its own mistakes, your entire command line toolchain has to be scriptable, parsable, and strictly reliable. Your CLI is the AI agent's user interface,
The agent is essentially living in the terminal.
living in the terminal.
And this fundamentally changes the code review triage pipeline. Because if the AI is generating massive amounts of code and running it through the CLI, human developers simply cannot review every single pull request the old way.
The volume would just crush them.
Yeah, the volume is insane.
So the source outlines a brand new triage pipeline to handle this volume. It starts with deterministic auto checks in the CI. If it passes that, it moves to an initial AI review.
Wait, an AI reviewing the AI?
Yes, essentially having a secondary AI model analyze the primary AI's code for obvious anti-patterns or stylistic issues. Only after surviving those automated gates does the code reach a human. This triage pipeline means humans see exponentially fewer trivial issues.
So developers are no longer wasting cognitive energy hunting for a missing semicolon or debating syntax formatting.
Exactly. The human is freed up to focus strictly on the high-level architecture, the security posture, and the semantic logic of the change. You are judging the intent of the system, not the spelling of the code.
Okay, that structural shift makes sense, but it introduces a really complex testing dilemma.
Oh, testing is a whole different beast now.
Right. If your CLI is tight and your CI pipeline is aggressively running tests, how are those tests actually written? We are dealing with code generated by a machine, which often uses logical pathways or structures that a human wouldn't naturally invent. How do you rigorously test logic you didn't even write?
This raises an important question, and it's where the presentation introduces AI native testing, which forces developers to think mathematically. One core concept is round-trip tests.
Round-trip tests.
Consider a function that performs a transformation. Let's call it t. And it has a corresponding inverse function, t inverse.
So a practical example would be compressing a file and then decompressing it, or encrypting a payload and then decrypting it.
Exactly. In the AI era, an LLM might generate both the compression algorithm and the decompression algorithm. The danger is that the AI might write a beautifully expressive but entirely flawed compression function and a similarly flawed decompression function that just happens to accommodate the original bug.
Wow, so they both fail, but they fail together perfectly.
Yes. If you write traditional unit tests by just reading the forward code, you might miss the systemic error. So AI native testing dictates that you test the composition.
You test the round trip.
You compress the data, immediately decompress it, and mechanically verify that the final output matches the original input byte for byte. The key insight from the source is that the test doesn't care about the internal steps of the forward function or the inverse. It strictly validates the integrity of the pair.
And the presentation also elevates property-based testing.
Probably.
Instead of writing specific edge case scenarios, developers have to establish absolute invariant truths that must hold for any valid input. For example, commutativity in an addition function.
Right, the math has to work.
Exactly.
Yeah.
No matter how convoluted the AI's sorting logic is, x plus y must always equal y plus x. Or sortedness, if the AI writes a function to filter a database list, the fundamental property is that the new list cannot contain more items than the original list.
That's the invariant truth.
Right. You aren't testing the specific steps the AI took. You are testing the unbending laws of physics for that data structure.
Because the AI's generation pathway is non-deterministic, right? You cannot predict the exact syntax it will use. Therefore, your tests must lock down the mathematical properties of the result.
But the presentation goes even further into the abstract here. It introduces the concept of using AI as a test oracle.
Yes. Using one AI to judge another.
Which sounds wild.
It does. In traditional environments, a human oracle manually determines the exact expected output for a given test case. But in the new dev loop, you can leverage a secondary independent AI model to generate the expected output and use that to judge the primary AI model's work.
Okay.
If two distinct AI models process the same prompt and their outputs agree, that mathematical agreement serves as a strong proxy for correctness.
See, the mechanism there sounds incredibly risky to me.
Right.
Using an AI to test another AI inherently sounds like a massive echo chamber.
It's a valid fear.
Right. If these large language models share similar architectures and were trained on overlapping internet datasets, couldn't they both just confidently hallucinate the exact same wrong answer? How is agreement a proxy for safety if the underlying logic is universally flawed?
Well, that vulnerability is central to the challenge of test oracles. The source directly warns against what it calls shared blind spots. If you use two models with the same training bias, they will absolutely high-five each other over a flawed solution.
High-five each other right off a cliff.
Literally. So the mitigation strategy requires differential testing. You must use fundamentally different base models.
Like what?
Perhaps one model optimized for reasoning and another optimized for sheer code generation. This forces cross-model verification. It enables automated testing at an unprecedented scale, but, and this is a big but, it demands severe human skepticism.
So you can't just trust it blindly.
No. You use the agreement to filter the noise, but the human must ultimately verify the logic of the agreement.
You cannot abdicate responsibility just because two neural networks reached a consensus, which leads directly into the macro consequence of this entire shift.
Yeah.
We've established the mechanisms to guide the AI, catch its hallucinations, test its non-deterministic logic. But what happens to the overall health of a software project when an engineering culture ignores this complex validation infrastructure and just, maximizes code generation?
Oh, they slam into the speed of debt.
The speed of debt. The harsh mathematical reality of this era. AI generates code 10 times faster. If you do not have the deterministic walls of CI, round-trip testing, and differential oracles in place, technical debt accumulates 10 times faster.
It's exponential.
The source lays it out plainly. AI does not change the fundamental laws of software engineering. It just acts as a massive amplifier of your existing habits.
High generation velocity combined with low validation rigor creates legacy code instantly.
Instantly.
To prevent a project from collapsing under the weight of its own generated debt, the presentation establishes a strict set of new golden rules. These are divided into protocols for human developers and protocols for AI agents.
Okay, let's analyze the human protocols first. Rule 1. Prompt is code. Your prompts can no longer be casual chat messages.
Right, no more, hey, build me a button.
Exactly. They are the foundational architecture of the system. They need to be version controlled, subjected to peer review, and tested with the same rigor as a core Python script.
Yes.
Rule 2. Review diffs, not files. Because the volume of generated code is so high, human reviewers must focus purely on the semantic changes, the delta, rather than trying to comprehend the entire generated document.
And Rule 3 for humans is critical for long-term maintainability. Always tag AI contributions in your version control. The source suggests a literal tag like git commit -m I:, followed by the message.
So an audit trail.
Exactly, the audit trail. When a subtle bug surfaces 6 months from now, you need to know immediately whether a human wrote that specific logic block or if it was dreamed up by a probabilistic machine. The debugging approach is completely different depending on the author.
That makes a lot of sense.
And there are strict rules for the AI agents, too. As we established, agents must operate via the CLI, scripting everything for perfect reproducibility. They must strictly respect quality gates. An AI agent should never possess the overriding authority to bypass a failed CI check.
Never. And the final rule for agents is atomic commits. An agent should be constrained to one logical change per commit. If an agent hallucinates a change across 50 files in one massive commit, unwinding that error through Git is a total nightmare.
It's impossible.
Right. Atomic commits mean you can surgically revert the specific hallucination without destroying a whole week's worth of valid architecture.
And to measure whether these rules are actually working, the source highlights hard performance metrics that engineering teams need to track now. Your AI code acceptance rate must remain above 70%.
70%?
Yeah. If developers are rejecting or heavily rewriting half of what the AI generates, it indicates that the initial prompts, the architectural instructions, are fundamentally flawed.
And your CI pass rates on AI-generated commits need to be above 90%.
Right.
And crucially, human review time per pull request must stay under 15 minutes.
That 15-minute metric is the canary in the coal mine. If a senior developer is spending an hour manually untangling the logic of an AI's code, the entire automation multiplier has failed. You're just generating 10x the busy work.
Right.
Those metrics dictate whether you are actually scaling productivity or just scaling chaos.
So what does this all mean? When we synthesize everything that LUK 036 has detailed for the 2026 landscape, the overarching philosophy boils down to a single, uncompromising equation.
The ultimate takeaway for anyone architecting systems today is this formula. Success equals AI velocity, multiplied by human judgment, multiplied by validation infrastructure.
Velocity times judgment times validation.
The brutal reality of multiplication is that a zero in any category zeroes out the entire result. The weakest of those three factors determines your absolute organizational ceiling. You could integrate the fastest, most advanced AI models in existence and employ brilliant human architects. But if your validation infrastructure, like your CI pipelines and automated testing, is porous, your success is fundamentally capped. True scale requires massive investment across all three variables simultaneously.
The transition from the old world to the new dev loop is a profound culture shift. The takeaway for you is that the value of an engineer has fundamentally changed.
It really has.
The premium is no longer on knowing how to write the syntax. The premium is on mastering how to direct the generation, rigorously validate the output, and securely integrate probabilistic code into a deterministic system.
The industry focus moves permanently from the mechanical act of typing syntax to the cognitive act of semantic design and systemic verification.
Which leaves a really fascinating implication about the future of this field. If prompt quality is the new code quality, and AI agents eventually handle all the actual expression of the logic, well, we have to wonder about the developers of tomorrow.
Yeah, the next generation.
Will the next generation of software engineers even know how to read the underlying syntax of the systems they deploy? Or will human coding, like the manual placement of brackets, variables, and loops, eventually become a lost art, replaced entirely by the pure communication of architectural intent?
It's a huge question.
It's like having a magic wand that builds the ship in the bottle, but eventually forgetting what a piece of wood even looks like. Something to think about the next time you prompt a machine to build something for you.
Absolutely.
Thank you for joining us on this deep dive. As always, keep exploring and keep questioning the systems around you.